Here in this section I'm showing you how to calibrate the pallet tester. Before starting the calibration procedure, first release these clamps from wire encoders. As I said, don't release this wire suddenly because it will damage the wire encoder. I'm releasing it and moving the wire slowly. Yeah, here. Then releasing the wires that is connected to the sample piece. Now we can bring sample out. I'm moving the hose plate up, and now we can release the sample. Okay. For force calibration of the machine, you need to have a reference force indicator and reference load cell. Then put the load cell under the force plate. Yep, put it in the middle. Yes. Make the zero. Make it 0. Then we going to the software, going to calibration. Without any load on the force plate, be noted for calibration, you need to set these bolts in such a way that this force plate touches the sphere connected to the load cell here. And there is need not to have any gap between the force plate and the sphere connected to the load cell. I mean, you need to set these bolts in such a way that to set these the compression of these springs, 4 springs on the 4 corners of the moving plate in such a way that the force plate touches the sphere and with no gap. Yes, this is setting of these screws. Then we are ready for calibration process. Now, without any load, without any touching of the force plate, you need to make the force 0. Just click 0. Then bring it down. Then bring the moving plate down. So that here you see an indicator, reference indicator showing the force. Now we have 2,300 kilogram. Now 4,000 kilogram applied to the reference load cell. And you will write here the reference value that the reference indicator shows. That one is in the unit of kilogram. You will input the kilogram value with the unit of Newton here. For example, now it's 4,052 kilogram. You will make it to Newton by multiplying to 9.81, and the value will be entered here. Then you will click scale. Now I'm not doing that because it's already calibrated. Then you will click on scale. Then you will click on quit. That's all. The force will be calibrated, and the calibration parameters, when you click on quit, the display of the software will be like this. The calibration file of the software is tension 1 dat and the root of D. Do not delete this file. Every time you need to have a backup of this tension 1. I'm copying this backup to backup folder to have a backup of calibration of the machine. You need to put this tension 1.dat in the root of D. Whenever software starts, run as administrator, it reads the data from this file. Then do not delete it. Now we already calibrated the load cell. The other parameters, now I'm releasing the force. moving the force plate up. Now the force is 0, and the displacement calibration are with these factors here. The factors set like this. For example, the pulse correction 2 here is for the encoder 1, encoder number 1. The encoder number 1 is with resolution of 101.653 micron. Divided this value by 2 will be calibration factor for the encoder, wire encoder number 1, that is pulse correction 2, because the pulse correction is for the encoder that is connected to the ball screw. The other one, pulse correction 2, is for encoder 1. Pulse correction 3 is for encoder 2. You will read the resolution on the wire encoder, divided by 2 and put it here. For the first one, you need to do like this. The wire, the encoder of the ball screw is with the pulse of 1024. And the pitch of the ball screw is 10 millimeter divided by 1024. That is the pulses of the encoder connected to the ball screw. This is the number of pulses per one rotation, and divided by 2 will be the value you will put here for pulse correction of the encoder of the ball screw. It's easy. Calibration of the displacement is really easy using these figures, and the load cell is as demonstrated. It's very easy to calibrate the force, and the displacement is calibrated. After displacement is calibrated, you need to put the max speed here. The max speed of the machine is 200. This is also calibration factor for the speed. Anytime you want to calibrate the speed of the machine, you need to change this value. Here you need to put 150, set to one direction, up or down. Then start movement, and using a stopwatch, measure the displacement of the moving plate in definite time, for example 30 seconds or 60 seconds, and measure the real speed of the moving plate of the machine. And if there is any difference and need correction, you need to multiply the correction factor to this value and put the new value to max speed. This is the value that you will need for the calibration of the speed of the movement. It's easy to calibrate the pallet tester from AHP Plastic Machina. Thank you.